Hello everyone, in this video we're going to be talking about converting mixed numbers to decimals. So first of all, what are the mixed numbers? Well, if you have a fraction, let's say for example 11 over 4, that has a, let's say, a larger numerator, okay, and the denominator is smaller, so 11 is larger than 4. So we can rewrite these in a different way, which for example, we could say how many fours are in this one, so 2, and then let's say, I believe it's going to be something similar like this. So we have 2 complete fours in 11, and also there will be a, let's say, a remainder, okay, the remainder of the division, which is 3 over 4. So if you have a fraction like this, you can write it this way. So this is called a mixed number. So anyways, we have actually 2 examples, and then maybe we will add 2 more at the end. Okay, so how do we convert these into decimals? In other words, having a point. So first things first, you have a, let's say, large number, which is the 7, and then a fraction next to it. So first step is always the easiest. So bring the large number, write it the same way. So 7, 7. Okay, and then put a point, right? So now we have to figure out what's after the point. Well, I'm gonna do this here. So we have 3 over 4. So 3 over 4 as a decimal, if you know it, you can immediately write it, but let's suppose that you actually don't know. So we want to change the fraction into the denominator specifically, into a 10 or 100 or 1000 or a multiple of 10. So how can we do that, you might be asking? Well, this is for, I know that if I multiply 4 by 25, so like this, okay, what do I get? 4 times 25 is obviously 100, and then 3 times 25 is 75, right? So this is 75 out of 100, so you can just say 0.75. Okay, you see what is next, or let's say after the point, is 75. So you can just copy this part and put it here, okay? So the mixed number becomes just 7.75, and that's it, okay? For next one, we have 2 as a whole number and then 2 over 3 as a fraction. So the same way we did for 7, you just copy the large 2, just write 2, and then put a point. And then bring the fraction, which is 2 over 3, and break it down. So we have to figure it out. Alright, so since this is actually 3, not a nice number like 4 that we can multiply and get a multiple of 10. So here I suggest that you get familiar with some common fractions. For example, 1 over 3 is 0.333 repeated. Okay, so 2 over 3 is 2 times that. So 2 over 3 is, multiply each digit by 2, so 0, 3 becomes 6, 6, 6, and it goes on forever. So this fraction is simply 0.66 repeated. So you can also just copy this, so 6, 6 repeated, all right? So we can actually do few more examples. Let's say if you have a fraction normally, and then you have to, let's say, convert it into a decimal, so not like a mixed number, you skip the mixed number step. For example, let's actually do the first example, 11 over 4, okay? So we want to convert this into a decimal, even though it's not a mixed number right now. It's not expressed as a mixed number. This is just a normal fraction. Well, for this, you just do the division. Okay, so you put 11 here and 4 here. You would say, how many 4s are in 11? Well, I have 4 and then 8, 12. So if 3 4s is gonna actually exceed the limit, which is 11. So that means I can only have 2 fourths in 11, which is 8. So I have to, then 2 times 4 is 8, right? And then we subtract, so take away 8 from 11, obviously 3, okay? So now, do we have actually 4 in 3? We don't, okay? So if you don't, you just put a point like this, okay, and add a 0 to 30. So now, how many fourths in 30? Well, I can confirm that, I think, let's see, 4, 8, 12, 20, 20, no, that's 16, yeah, 20, 24, that's 6 fourths, 28, so we have 7 fourths in 30. Okay, so now 7 times 4 is 28, okay, so you can subtract these also, so you get 2 again, okay. So now, how many fourths in 2? None. So you can put a 0. So how many actually fourths in 20? How many? Exactly 5, right? So now multiply 5 by 4, you get 20. Subtract, you get 0. Since the remainder is 0, so that means the division is complete. So this above part is going to be the result. So 2.75 is the result for this. Okay, we can actually do one more just to master this conversion. So let's say 17 over, let's say 3, okay? So again, you do a long division, so 17 and then 3. How many 3's in 17? Well, 3, 6, 9, 12, 15. And if you add one more and say it's 6 3's, it's gonna become 18, which is more than 17. We don't want that, okay? So I can use an easier method also. So 3, 6, 9, 12, 15, 18. Okay, so we stop here. So how many? 1, 2, 3, 4, 5. Okay, so we have 5 of those. So now 3 times 5 is just 15. We subtract these, we get 2. Again, some of the steps that I do is quick. You can always let's say watch the video again or go back 10 seconds to get the hang of it, right? So now again, how many 3's in 2? None. So you put a point like that, you add a 0. So now how many 3's in 20? Well, if you use the same table I used, well, you're gonna get 18 before 20, which is only 6 3's, all right? So now 6 times 3 is going to be 18. You subtract, okay, you get 2. Now you can go on and say how many 3's in 2? None. Yeah, so we add a 0. So again, how many 3's in 20? 6. So again, 18. You get the idea. So this is gonna repeat like this. So it's going to be 5.6 repeated. Okay, I could say that this is enough for the video, but as a extra, I will teach a special way to do this also. Even if you don't understand this one, it's fine, but it's a special way. So you have 17 over 3, okay? We can break this down into 15 plus 2 over 3, all right? Now, we know 3 is a common denominator, so this becomes 15 over 3 plus 2 over 3, okay? 15 over 3 is simply just 5. 2 over 3, we mentioned this before, it's actually 0.666. So, if you can actually recognize this, you can immediately say this is 0.66, so you get the same result.